Alright, next let's look at a multi-argument macro, right. So effectively what I have over here is I am using it to define something called max of x comma y, right. And what max of x comma y does is it checks if x is greater than y, if so it returns x, else it returns y, okay. And sure enough, if I run this, it actually prints out max of x 7 comma 9 is equal to 9, because that's basically what I had out here as the string that I wanted to print, right. Now you can imagine that there are problems over here, and yes there are, right. I mean, so this has all the same difficulties that we had with single argument macros. So the correct way of writing this should actually be to put in parentheses out here, to put in parentheses out here. You probably don't quite need to have parentheses around the entire x greater than y, but it's probably safe to put it in anyway. You definitely need to have it around the x and around the y over here, and of course you need to have it right from one end to the other, right. So all of this was just to sort of play safe, to make sure that you do not end up with a precedence related issue and thereby end up getting the wrong answer, right. What happens if I run this? Of course I get exactly the same result, because it wasn't wrong to start with, right. For 7 and 9 at least it just works. But if I had put in other kinds of parameters, then I might have found that things go slightly different. In general over here, if you do have something like 7 plus 3 and 9 plus 2 or something like that, it should work, because the arithmetic operations would actually be evaluated before the greater than. But there can be other scenarios where things could go wrong and not quite behave the way that you expect. Now of course all of this works provided that you are working with arithmetic, that is with numbers, right, because putting brackets around numbers doesn't change their value, it's perfectly fine, it's valid. But there can be scenarios where just putting extra parentheses around something, for a string for example, actually changes what it's trying to do. So you need to be a little careful when you're writing macros, but given that a lot of macros are used for this kind of arithmetic expansion, this is a sort of valid way of doing things. Now as I already mentioned, why would you use a macro in the first place over here instead of a function? That's simply because this one macro works for integers, floats, doubles, any numeric type without requiring any additional code. And the reason why it works is because literally this piece of code is going to get expanded out where I have this max of 7, 9. By the way, you hopefully also notice that this max of 7, 9 which was there inside the string was not touched, right. So it doesn't go around altering things everywhere. It's when you have something as a free piece of code out here that the preprocessor kicks in and replaces it with whatever you have defined it to be. Now one more example of what you can do with macros, right, and let me just take modify this slightly. I've just taken out 2 lines over there because I'll need to explain them a little bit more as we move forward. You can see that I've defined a new macro out here which I've called print all, okay. So this macro print all takes an argument a, and what it does is it first computes a new internal variable. Why is it internal? Because you can see that the very first thing in the macro starts with open curly brackets and goes on until the close curly brackets. But the important thing is actually not here, it's at the right hand side over here on column number 81, right, in the case that I have over here, right. You will notice that there is a backslash. Now a backslash at the end of a line in a programming language like C is called a continuation, and what a continuation does is it basically says that this line is not over yet, right. I want to continue on the next line. And the way that it does it is it basically says you need to have the backslash and a carriage return, backslash n in other words, right, enter immediately after that. There cannot be another character after the backslash, right, you need to go to the next line immediately after that. But now what it has done is it basically says that this print all of a will be replaced by everything, this entire continuation, until I finally hit this line that does not have a backslash at the end of it, at which point I stop. Okay. So this whole thing, when I call print all out here, it's going to basically go through and print everything and replace that macro print all with this entire piece of text. Okay. Remember, this is still only text expansion, right? It's replacing the word print all of A with this entire piece of text. Now what does that piece of text do? It starts a new block with curly brackets. Within that block, it declares a variable called len equals size of A divided by size of int, which tells me as a user that it is probably expecting A to be a fixed size array of type integer, right? And then I run a for loop that says for int I is equal to 0, I less than n, I plus plus, printf A of I. Okay. Now let's see how this works. I declare an int array of fixed size 5 over here as having the values 1, 2, 3, 4, 5. I initialize it also. This is known, we know how to do this. I also declare another array b and just initialize the first value of b to be 7. Once again we know what this does, the remaining values of b will be set to 0. Now I just call the macro print all of a1. I also call the macro with print all of b, right? And what exactly happens when we run something like this, right? Let's just try this out. So when we have this code with print all of a1 and print all of b and we run this code, what we find is that it basically, what it has done is it first printed out the values 1, 2, 3, 4, 5, which if you look at it, is basically the output of a1, and it also printed 7 followed by 6 zeros, which we know is the output of b. So in other words, it has gone through, it has calculated the length of a, the number of elements in a, it has written a for loop which goes through all of the elements of a, and it has printed out all their values. Okay. So this is really where the power of macros starts to come in, right? If I had wanted to do this at one shot, I would actually need to write a function that takes in a variable length integer as an argument, and something like this len equals size of a by size of int would no longer work, because when you pass an array of integers as an argument into another function, it loses that size of parameter. From that point it only takes a as a pointer, and if I try running size of, it would basically give me the size of a pointer, right? So actually speaking, if you just use pure functions, it's not even clear that you would be able to achieve this particular output, right? It gets more interesting. I could, for example, take this particular line and add it into the code out here, right? And let me just uncomment that. Now if you look at what this line does, right, printf, and it says name of the variable, it has a %s out here, a string, and this is a strange new notation. It basically says hash a. Okay. Now what hash a does is, it does something called stringification, right? For want of a better term, we call it stringification, which basically says that I take the whatever is the token, in this case the name of the variable, and convert it into a string. So what will happen when this macro is expanded is, this particular hash a will be replaced by a string with the value a1, right? And I can also of course print out the length that I have out here. Right. So both of these, of course, in order to do that, I first need to compute that length. So yes, here it goes, right? I first compute the length and then I print it out. If I had not done that, it would have resulted in a compile time error actually. Now let's see what exactly happens over here. When I run this, it actually says name of the variable a1, length of the array 5, name of the variable b, right? This is pretty interesting if you think about it, because when you actually compile a C program, after you have compiled it and when you run it, in general you do not have a way of recovering the name of a given variable, right? So if you were to write a function that basically wants to print out the name of a variable inside it, it doesn't have access to those names because those names are replaced by memory addresses, right. Whereas because this is a macro and because it happens at compile time, what has actually ended up happening is that I literally have this code out here saying printf and so on out here, at which point this hash a has been replaced by the string a1, which is why it was able to print out the string a1 out here, and similarly the string b out here. The name of the token could actually be used by the macro, right. So this sort of gives you fairly powerful capabilities, especially for debugging, right. And on a related note, there is one minor thing that is worth sort of bringing out over here, which is that I also have one, just like this hash a that we have out here, we also have the capability of concatenating two arguments together, right, where it assumes that the arguments are basically treated as strings and puts them together, right. So if I do cat a comma b, it will actually just create a hash hash b, right. What happens when I run this? I actually get hello world out here because it has literally taken this h and space w, right. It actually takes the space w and puts it in over there and creates this parameter that I have out here, right. Sorry, actually what has happened over here is that it has actually taken the h and w, replaced it with hw, which actually happens to be a macro that I have defined up here saying hello world, right. So the fact that I defined h as hello and defined w as something else over here is completely irrelevant, right. It did not even make use of that. What it did was it replaced this cat of h comma w with hw. It then went and replaced hw with hello world. You can notice that this is a lowercase w as opposed to the uppercase w that I have here, and printed that string out, okay. So this kind of a thing, string concatenation, can also be used in some sense for interesting purposes, I mean basically for creating new names of objects and so on. However, this is comparatively less useful. Something like this, a multi-line macro that you have out here, especially where you can even get the name of a token and so on the other hand, does have fairly interesting uses, especially when you are looking at debugging programs, right. This actually effectively gets into the realm of something called meta programming. Effectively what we are doing over here is we are generating programs, we are creating programs using constructs that are not part of the language itself, and that is precisely where the power of macros comes in. So there is another very interesting set of macros that are made available to us as part of the C language itself, right. And a lot of these essentially have a specific form. They take the form underscore underscore some name underscore underscore, right. Again, this is a convention. There was nothing fundamentally requiring that this is how it had to be defined. They are just macros like any other macro. But the interesting thing about these macros is what happens with the C compiler is the moment it sees this underscore underscore func, it actually takes the name of this function, built-in underscore 1 in this case, and puts it in here. Now that's really interesting because if you think about it, that's only something that can be done at compile time, right. At runtime you might have a name corresponding to a function, but you don't really have it as a string somewhere that you can then put some into a printf statement. Similarly, and this is even more interesting because it allows you to print what the name of the file was, right. And this information is certainly lost by the time you get to an actual execution of the program, because what happens is the compiler compiles many different files together and creates one executable by combining all of them, and the information about which file contained which program is pretty much lost unless you have some kind of macros of this sort. Once again, this is done at compilation time, which means that this %s is replaced by the name of the file as it stands at the time of compilation, right. It also stores the date and time of compilation in the program itself. In other words, when it's actually running the compilation, it replaces these things with the time at which it's running the compilation. And it also has something about the line number at which you are currently. There is also something called the standard C version, right, which is basically referring to what version of C was the compiler following when it compiled this particular piece of code, right? Now, there are a whole bunch of other such built-in macros, some of which are generally useful, especially the file and line and so on can potentially be very useful for debugging, right? And some which are probably more of interest to someone who is actually going in and manipulating the program itself, right, or the compiler in some way. Anyway, let's see what happens when we run something like this. It actually gives you all the details. The name of the function was built-in _1. The name of the file was main.c, right? The line number is 81, which you can see is the exact line number where the __ line parameter was used. It also gives you the date on which it was compiled, as well as the version of the C compiler that was used, or rather the version of the C standard that was being followed by the compiler in order to compile this program.